This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to finish up our Orbital Ellipse series by using our Ellipse class that we created to create this sort of a solar system scene and start getting some planets orbiting around a sun. So in order to do that, we're going to start by creating a new scene. And as you notice right now, nothing much has changed. I think this actually opened up with an empty scene. But I'm going to quickly make some changes here. I'm going to take off the 2D in the scene setting. As well, I'm going to go to the main camera and change it from an orthographic view to a perspective view. And that just sets us up so that now we're kind of viewing this scene in 3D space rather than as a 2D project right now. Ideally, you'd want to start a brand new project with 3D, but rather than having to dump in the old classes that we made and stuff, I figured I would just work with this project. So with that done, I'm going to quickly save this as, we'll call this Solar System. And one last thing I'm going to do here is in our camera, I am going to change the color of the background to a dark gray, not quite black, but just to give it a little bit more of a spacey feel. Now, in order to create this solar system, we need to have a sun and some planets that are going to orbit around it, and the hierarchy of how we build that is actually going to matter quite a bit. So to start, I'm actually going to create a empty game object in our scene, and I'm going to call this sun. And this is, but bear in mind, this is just an empty game object. It is not a sphere. I'm not, creating the model here because I want to keep all of my models separate from their sort of container objects. Basically so that if we need to scale stuff or we need to do anything, like if I want to, make the sun shake for some reason, if there's some disastrous occurrence happening, I don't want to then be shaking the rest of the solar system the exact same way. So I want to keep that model kind of separate in the hierarchy. So how I'm going to do that is I'm going to create under this sun, I'm going to create a 3D object sphere, and that's actually going to be our sun. So this I'm going to call sun model. I'm going to increase its scale to about 1.5 on all axes, and I'm actually going to create a custom material for this, and I'm going to call this sun material, nice and straightforward. And I'm going to change the shader to an unlit color shader. And white actually works pretty well for that. So we're going to pull that and add that onto this. So now we just have this big, bright, glowing sun. You could certainly change the color if you wanted to. In addition, on our sun model, I'm going to add a light component. So that, and this is going to be a point light, range of 10, should be pretty good. We can adjust these if we need to. But basically what this is going to do is now, it effectively, this sun is going to be kind of casting light from itself, much like a sun would in space. Now for the planets, I'm actually going to do something similar where we have this empty game object, and that's actually going to be what we're going to put our orbiting control class onto. So I'm going to go into the sun here again. I'm going to say create empty. And this I'm going to call, we will call it planet. That's okay. We're going to keep the transform at 0, 0, 0. So technically speaking, this planet empty object here is actually based right in the middle of the sun, but that is not where the actual planet model is going to be created, or is going to appear. So we're going to create that next. I'm going to right-click on the planet now and say 3D object sphere. And now this is actually our planet model. I'll pull it out. The position isn't, we can actually kind of position it wherever we want in our scene view right now because the, like I say, that orbit control class is going to reposition this for us in just a minute. I'm going to scale this down a little bit. I'll scale this to about 0.25 maybe on all axes. So now we have this smaller planet object as well. And I am going to rename this sphere. We'll call this rename planet model. So again, it's really this kind of this structure of that we have empty game objects that are what we would use to position things and do things like that. And then we have the model itself, which is kind of separate so that now I can move this sun around and it's not affecting the planet that's associated with it. I'm going to cancel that. Now this is saying, is that because, the reason, if you noticed here, suddenly my game object looked like it wasn't appearing. It doesn't seem to be happening now anymore. That's a little bit odd. Forget what I said there. Was sort of, it had this appearance that the, it kind of actually does have this appearance here that the transform is not right at 0, 0, 0. And the reason for that is that I have my pivot here on center, which means it's kind of centering it based on all of these versus actually at its pivot. So I'm just going to switch that to pivot here. We'll keep the axes at global, and that way that's centered right at that 0, 0, 0 point. Now, with all this in place, I can now create a actual orbit kind of controller class. What this class is going to do is it's going to operate from the center here, right, kind of from the center of the solar system, but it's then going to tell this planet where it should be in an ellipse around that position. It's kind of like, almost in a way, the center of the ellipse, and then the planet will move in kind. So what I'm going to do is create a new C# script. We'll call this orbit motion. That's really what this is controlling. And I'm going to add that to our planet. As soon as it compiles, I'll add that to our planet object. With that in place, we can now open that up in MonoDevelop. Zoom in a little bit here. And I'm going to get rid of our update function. We're not going to need that for this particular script. What I am going to create, though, are a few variables that we need. The first one is a public transform called orbiting object, and this is actually where we're going to put that planet model. This is going to be what we reference to control the motion of that planet model. And then we're going to have a public ellipse called we'll call this orbit path, and that's going to give us the that serialized ellipse object, so we can set where we want the two axes to be. And then we'll create a public float called orbit progress, and this is going to basically be a number between 0 and 1, much like how we have our 0 to 1 for finding the angle and then finding the sine and cosine and the position of the ellipse. This orbit progress is basically saying, how far along the path of the ellipse am I? And we are actually going to create a attribute up here. We're going to give this a range attribute between 0 and 1 so that we're always between those two numbers. In addition, we're going to have a public float called orbit period. And this is how long it's going to take in seconds to go completely around the orbit one time. We'll actually set that to like 3 to start. And I'm actually going to also set this just to 0 as a default for the orbit progress. And then lastly, we're going to have a public bool called orbit active, and that'll be equal to true. And that's basically going to tell us if there's ever a time that we wanted to turn off the orbiting, that we just wanted to focus in on a planet, not keep moving it around, we could just turn off that and kind of pause the orbit, if you will. Now, in our start function, I want to quickly double check before we start trying to move stuff around that there is in fact stuff to move around. And so we're going to do that by checking this transform and making sure that it's not null. So we'll say if orbiting object is null when we start our scene, then we can set orbit active to false. Now, I don't know why that jumped down there on me. There we go. And we're just going to return. However, if we do have an orbiting object, then we can quickly set that orbiting object's position. I'm just going to put this as a comment right now because I want to make this into a function. And I'm going to also then start orbit animation. And actually that's only going to happen if orbit is active. Because bear in mind, while this will turn off the orbit active if there's no orbiting object, we may also be starting our scene with this as set as false for some reason. So we want to make sure we're not setting orbits when we don't want them. With all that in there, now we can actually create this first method that's going to set the orbiting object's position. So I'm going to do a void set orbiting object position. Nice and clear here what we're doing. And what this is going to do is this is going to look at the current orbit progress and then look at our orbit path and kind of evaluate what the position should be. So we're simply going to say, we're going to create a vector2 reference called orbit POS, orbit position, equal to the orbit path dot evaluate, which is that custom method we created, and we're just going to pass in the current orbit progress. From there, we can actually take our orbiting object and set its local position equal to a new vector3, which is the orbit position dot x. Y is just going to be 0. We're going to assume that we're always kind of operating on this xz plane for these. And orbit position dot y for the z position, which is a little bit, we're kind of going from an xy to an xz here. So now we can, instead of setting the orbiting position as a comment, we can actually say set orbiting object position. Lastly, we need the orbit animation, and we're going to handle that with a coroutine so that we can every frame look, see where the planet is, and then continue from there. So we're going to say enumerator animate orbit. It's not going to take any parameters. And in here, we're going to quickly check and see. Now, how we do this is we're going to use time.delta time to see how far along the orbit we're moving every frame. And to do that, we actually want the inverse of this, because we don't want how long it takes to get around it. We want the inverse of that to figure out how fast it should be going. But to calculate that every time is not super efficient. Division is actually one of the least efficient things you can do in basic C# math. So we're going to quickly create a kind of cached reference here when we're doing the animating. So it's going to be local to this coroutine. But I'm going to create a float called orbit speed. And this is going to be equal to 1f divided by the orbit period. There is one situation too that I want to be careful of, which is that if we were to create if we had an orbit period at like 0 or even something very close to 0, it would be incredibly fast and likely not what we want at all. So I do want to just have a quick sanity check before this to say, oh, is the orbit period really close to 0? If so, kind of set it to some kind of minimum. And I'm just going to kind of arbitrarily choose 0.1, so the fastest this thing could go around is every 10th of a second, which is still probably even too fast, but at least it won't, break our system trying to divide by 0 here. So what I'm going to do is I'm going to simply say if orbit period is less than 0.1f, then set the orbit period equal to 0.1f. So it kind of minimizes out there. Now, there might be a situation where you want to have orbits that are actually negative speed going in the opposite direction. There's a couple ways you could solve for that. One is that you could change this orbit period to a negative number. That's actually a little bit weird because technically you're not going backward in time. But that, if you wanted to, you could just double check that the absolute value is not less than 0.1 instead of just the entire value. But we're going to stick with this for now, makes it a little bit simpler. So double checking that the orbit isn't too close to 0, and then creating the speed based on that orbit period. From there, what we're just going to do is we're going to check every frame. We're going to say while orbit active is true. So long as that is checked off, we can keep doing this. And we'll say orbit progress plus equals time.delta time, so the amount of the time that the frame has taken, multiplied by that orbit speed we just created. From there, we're also going to quickly say orbit progress modulo equals 1f. And that's basically going to say that if we go beyond 1f, or 1 in float, we're going to reset back to between 0 and 1 so that we're not kind of adding and adding and adding to this float, and eventually over time we could actually technically exceed the float value, the max float value, and that would be bad. So we're just going to quickly avoid that there. And then with that information, then we can now set the orbiting object position. And that will once again just check this number here at this point and set the planet's new position based on that. And then we simply have to yield return null so that we can go to the next frame. And then this loop will continue again and again and again until we turn off orbit active. So with all of that, we just have to quickly start our coroutine in here. So we'll say start coroutine, animate orbit, and this should be ready to go. We can jump back over to Unity now. We have our planet object. We want to make sure that our planet model is placed into our orbiting object. We have our orbit path. Now the axes are at 0 right now, so we want to make sure that we increase those a bit. Now let's see here. Where is the planet model there? That's at about 2.6 in this direction. So yeah, we'll say about 2.6 there, and maybe about 5, give it a nice wide orbit. Orbit progress, we can start at 0, that's fine, and we'll keep that 3-second orbit period. So with all of that done, we can hit save. I don't love where our camera is right now. Our camera is still set up for like a 2D view. We can't even see the planet right now. So I'm going to move it up just a little bit and then tilt it down. And you can do this a little bit further even. There we go. Now we can actually see the planet in question. And so now when we hit play, we should see that the planet is now orbiting around the sun. If we go to our scene view here, you can see it's making that nice elliptical shape. So it's not kind of just a basic circle going around. It is this full planet. It's going a little bit quickly, but that's okay. We can obviously adjust that as we like. I can go back into here, planet, maybe give it like a 6-second. We'll have the speed. 6-second orbit, and it goes around now. It's nice and calm. And we can even go so far, if we want to, as to duplicate this. Create a couple new planets here. This one, maybe we'll put the y-axis at about 4 and the x at about 7. And maybe we'll put the progress ahead a little bit there, 0.4. And then our last one we can even put even further out. Maybe we'll go 8 and 10, so a little bit, maybe 8 and 9 even, make it a little bit more circular. And we'll put this one's progress around 0.7, and maybe change this one's orbit speed to about 12, we'll say. So now what we see when we hit play is that these all get moved out, and now we see them all moving around at their own speeds in their own elliptical orbits. This one's going slower than these two, and yeah, that gives us our planets orbiting around. Now, one thing I did think about with this was, should these planets, right now these planets are always staying in the exact same rotation. They don't actually like orbit to face the sun or orbit or rotate based on where they are in the orbit, and that's actually more accurate. And a planet's orbit is based on its own rotation, or sorry, a planet's rotation is based on its own rotation, not where it is in its orbit. So really that would be like a separate thing that you would create, which is really just a simple local rotation that you can add to the planet itself. So this is actually somewhat physically accurate in that you can make the planet rotation independent of the orbiting position. And with that, you can start setting up your own space scenes, have some cool orbits going around your world, and hopefully make some cool games out of it. So thanks so much for watching, and I'll see you next time.